All right, so in this video, we're going to go through sample question 93 from the Society of Actuaries ExamP list of sample questions. The question reads, a family buys two policies from the same insurance company. Losses under the two policies are independent and have continuous uniform distributions on the interval 0 to 10. One policy has a deductible of 1 and the other has a deductible of 2. The family experiences exactly one loss under each policy. Calculate the probability that the total benefit paid to the family does not exceed 5. Okay, so this is a joint probability density question. With a lot of these, what we're going to want to do is draw out a diagram. So let's start with that. Okay, simple enough. Let's say the first policy, the losses are represented by X, and the second, the losses are represented by Y. So I have this diagram here. This is my X, this is my Y, and they're uniformly distributed from 0 to 10. And that uniform distribution is going to come in handy, especially for a question like this. When you have a joint uniform distribution question and you want to calculate a probability, you're not going to do any calculus, right? Typically, to find a probability when given a density, you integrate. With uniform joint distributions, you absolutely do not need to. You can kind of turn this into a geometry question. And that's why the diagram is going to help out so much. So let's see what this tells us. It says the first policy, this guy, has a deductible of 1. Okay, so let me just put in that deductible of 1. Right there. Right, so that's my deductible of 1. The second policy, this guy right here, deductible of 2. So I'm going to put in that deductible of 2. And what am I looking for? I'm looking for the probability that the total benefit does not exceed 5. Keep in mind, benefit is not the same thing as loss. It's a very easy thing to just miss when reading the question, right? It's a very obvious thing. It's not like I need to teach you that, but it's a very easy thing to miss. So we need the total benefit, which would mean the loss, right? Because it's a deductible of 1 minus 1, plus the second policy, the second loss, minus 2. It must not exceed 5. This has to be less than 5. Okay? And with just a little bit of algebra, x plus y minus 3 less than 5. X plus y is less than 8. And then y is less than x, negative x plus 8. Okay? And I can graph that line. So here I'll have 8 and draw that line down. Now that line goes down to when y is 0, x is 8, so 8 here. And I'll draw that line down. Okay? So now that we have this, we can start figuring out, all right, let's look at the situations where our actual policy is less than, the actual payout is less than 5. Okay? We have a few different situations. So one situation would be where where both policies actually pay out, meaning the loss exceeds the deductible, and you're less than 5. So that accounts for this triangle right here. Is this orange? Yeah. Not a big fan of orange. Yeah, that looks good. Right. So the other situation is where, okay, maybe the first policy didn't exceed the deductible, but the second policy did. All right. So that's from here all the way to 7. And this actually should be a little bit lower there. It's creating a rectangle. Okay, So that's that rectangle here. And the other situation is where we have a, so I should mention that this also includes when there is zero payout, right? That's this box here. However, what's left is for when you have for the second policy, a loss that does not exceed the deductible. For the first policy, a loss that totally does exceed your deductible, right? And that's going to be at 6 right here. So we have a few different shapes that if we calculate the area of, right, and then divide by the total area of the square, we could then get the probability of landing in this area. All right, so let's do that. Let me grab a separate sheet of paper. I'm going to reuse this paper that just doesn't have a lot on it. Like that. Save some paper. Don't call me a hero. All right, so let's look at the area of this rectangle here. Area of this first rectangle seems to be 1 by 7, which is 7. The area of this rectangle here seems to be, it goes from 1 to 6, so that's 5 by 0 to 2, which is 10, so plus 10. Now we're looking for the area of this triangle. Now, this triangle goes from 2 to 7, so that's 5. It goes from 1 to 6, that's also 5. So 1/2 base times height is, right? Do that right? Yes. Plus 1 over 2. Base, 5 times height, 5. And that's going to be 7 plus 10 plus 12.5. Right, 25 divided by 5. And this is equal to 29.5. Now, that's going to be our numerator. And I hope that it's easy to see the area of this 10 by 10 square is 100. So our probability, 0.295, which rounds to answer choice C. All right, so main takeaways from this problem. When you have a joint uniform distribution and you're looking for probability, don't do any calculus, do geometry. All right, you're going to want to make a diagram. First, figure out, okay, my first random variable goes from what to what, my second random variable goes from what to what. That's how you get the these bounds here. And then start, based on the context of the problem, adding in your restrictions. All right, I know the payout must be less than 5. So that's how I got this equation and drew in this line. The policy have deductibles, so that's how I got these numbers 1 and 2. I have to account for the different situations. I'll actually get a payout of less than 5. There are technically 4, right? Where the first policy pays out, but the second one doesn't. The second one pays out, the first one doesn't. They both pay out, or neither pay out. Okay? And then that leaves us with these little parts here, which I'm sure have tripped plenty of people up, and they've just taken the area under this triangle. Right? But once we have those restrictions put in, then just do some geometry, right? Know the area of a triangle, know the area of a rectangle. Simple enough. If there are any questions, throw it down in the comments. I will answer it to the best of my abilities. If this video helped you out, hit the like button, because that totally helps me out. Subscribe, that helps me out even more. And if you want to see more videos like this, I have a playlist, Sample ExamP questions. Check it out. But other than that, thanks for watching, and I hope this helps.